We often sometimes use vectors, and sometimes they're described as if you go back to geometry days, as rays would be. And here we're looking to find information about the ray PQ. Keeping in mind that PQ and QP, as far as rays or vectors go for that matter, are two different vectors. I mean, they follow the same path, they're going to have the same magnitude, but since they head in opposite directions, and vectors being, trying to think, but having both magnitude and direction as compared to a scalar that has only magnitude only, the direction is part of the value of that vector. So you're not going to say PQ and QP are the same thing. So when they say the vector PQ, it means you start at P, end at Q. So when you start describing the movement, you're starting at P, going to Q. So that's going to affect how you would carry through a subtraction, for instance. Because usually if you're describing a movement, you're doing differences between your first and second coordinates, and that's basically, what you're looking for. But you have to make sure you subtract in the right order, because as we know, subtraction is not commutative. I cannot reverse a subtraction and get the exact same value. I'm going to get an opposite value if I subtract in one order than compared to another. So since I'm starting at P and ending at Q, any subtraction I would be doing would take a coordinate from Q and subtract away the corresponding coordinate from P. Or I could look at it in terms of, if I start at P and end at Q, like how far have I moved in what direction? So if I look at the x coordinates for part A, if I start at positive 3 and end up at negative 9, that means I moved 12 to the left. So I would have a negative 12 movement because left is negative. And if I start at 4 and end at negative 1, I've moved down 5 units. So that'd be a negative 5. Let me get this thing to advance. So my vector PQ would be negative 12, negative 5. Okay? As far as the magnitude goes, still the same thing. I'm going to use the Pythagorean theorem on those two values. I end up with the square root of 169, which is about 13. So the magnitude is 13. Magnitude is always going to be positive. Okay? It's a scalar quantity. Scalar quantities are always going to be positive for the most part, because we're describing a distance or the amount of movement, not the direction of movement. If I look at B, I can look at it from the way I did it, or say, okay, well, if I'm going to go start at P and end at Q, I'm going to take the x coordinate of Q minus the x coordinate of P, so 1 minus 4 would be negative 5, and same thing if I do 1 minus negative 7, I would get 8. So, negative 1 to 4, negative 3, I don't want to say negative 5. Negative 3, 8 would be the vector PQ, and again, the magnitude is going to be done by doing the Pythagorean theorem on that. So I end up with the square root of 9 plus 64, which is the square root of 73. If I want to evaluate it further beyond that, I'd have to use an irrational number and approximate it. So that's a suitable enough answer for that. So we've talked about addition and subtraction. We've talked about scalar multiplication, which means that if I take a vector and multiply it by a single number,